Hello guys, today we are continue solving paper 4 2019 May-June variant 2. Question number 2. Figure 2.1 shows the model fire engine. Its brakes are applied. 0.80 kilogram of water is emitted in the jet every 6 seconds at a velocity of 0.72 meter per second relative to the model. Calculate the change in momentum of the water that is ejected in 6 seconds. As you see, we have the mass, which is 0.80, so this is mass of water. And here we have the time, which is 6 seconds. 0.72 meter per second, which is the speed. He asked me to calculate the change in momentum. You know that change in momentum equal mass multiplied by velocity. So delta P equal M times V. So it will be equal mass, which is 0.80 times speed, which is 0.72 equal 0.58, and you know that the unit of the momentum will be kilogram dot meter per second. Kilogram dot meter per second. Okay, next. B. Calculate the magnitude of the force acting on the model because of the jet of water. He asked me to calculate the force. You know that the change in momentum equal impulse. If you remember, change in momentum equal impulse. So change in momentum, which is delta P, equal impulse, which is equal force times the time. So change in momentum equal force multiplied by time. He asked me to calculate the force. So the force equal delta P, which is change in momentum, divided by time, equal change in momentum, which is 0.58 divided by time, which is 6 seconds, will be equal to 0.096, and the unit of the force is Newton. That's it. Okay. C. The brakes of the model are released. State and explain the direction of the acceleration of the model. He asked me to write the statement and the explanation, and we have 2 marks. He said the brakes of the model are released. So do you think, what about the direction of the acceleration? Will be to the right or will be to the left? He said the brakes are released, so the speed of the model will decrease. The speed of the model will decrease. So this means that the acceleration will be to the right direction, means backward. So we can write here acceleration to right means backward. Okay. Explanation. Why the acceleration will be to the right or backward? Why? Because the force from the water on the model will be to the right, because the force and acceleration will be in the same direction. Acceleration to the right, and also the force from the water on the model will be to the right, and acceleration in the same direction as force. Acceleration will be in the same direction as force. So force force from water or on the model to right, okay, or I can say acceleration in the same direction as force, as I said, acceleration in the same direction as force. So, as I said, acceleration to the right, backward, an explanation because the force from water or on the model to the right, or slash you can say acceleration in the same direction as force. D. In C, in this point, the model contains a water tank which is initially full. As you see, water tank full with water. State and explain any change in the magnitude of the initial acceleration if the brakes are first released when the tank is nearly empty. What will happen when the tank is nearly empty? What will happen to the acceleration? I think the acceleration will be more or will be less. The acceleration will be more. Why? Because it's logic. Because it's mass, what will happen to the mass? The mass will be less. Because, as I said here, nearly empty. The tank is nearly empty. So we can say here, acceleration more when empty. Okay, and as I said, why? Because the mass is less, massless, and the force is constant. Force is constant. And I want to add another thing here. Here, if you remember, the mathematical formula of Newton's second law, you know that F equal M times A. Force equal mass multiplied by acceleration. And as you see in this problem, the force is constant. So this means that, what is the relation between mass and acceleration? We have inversely proportional between mass and acceleration. Means, if you have less mass, you have more acceleration. So that will happen here in this problem. The mass is less, so the acceleration will be more because the tank is nearly empty, right? Due to the Newton's second law. So, as I said, mass less and force is constant because F equal M times A. So inversely proportional between M and A when F is constant, between M and A when the force is constant, when the force is constant. Okay, so the acceleration more when empty, as I said. So the mass less and the force is constant because F equal M times A due to the mathematical formula of Newton's second law. So We have inversely proportional between M and A, mass and acceleration when the force is constant. Okay, that's it. Thanks a lot.